here, secret presentation. They turned out the lights on me. We're presenting for the Triangle.net user group. So Trinug, another good organization in the RTP area, and we're going to talk about types and measures in F# tonight. So thank you everybody for coming in. My name is Kevin Feasel. I'm a manager of a predictive analytics team a couple blocks down the road here. I'm a Microsoft Data Platform MVP. Have a blog called Curated SQL. The idea of Curated SQL is that I want to try to find and link to 5 to 10 interesting posts per day on topics like database administration or development, Hadoop, Kafka, Spark, Power BI, R, Python, reporting services, security, or anything else in that broad data platform space. So that's curatedsql.com. Topic tonight is types. All programming languages have types. Now, some of them are a little more fleshed out than others. Something that is a bit more unique to F# is this concept of units of measure. And we'll get into both of these topics tonight. So what I want to give you is a better understanding of what types are and why they're useful, and then show the F# type system and also how in C# you can do many of these things. So we'll talk about how they're similar, we'll talk about where there are differences, and then we'll wrap up with some units of measure. So our basic agenda, starting out with types. At its core, a type is nothing more than a restriction. We're limiting you to certain values. So in other words, if I declare that this is an integer, well, we know that it is going to be a number. We know that it will have a value ranging from negative infinity to positive infinity. And we know that there is no decimal point. If I limit it further and say it is a natural number, then we know that it starts at 1 and goes toward positive infinity. If I tell you that it's a 32-bit integer in C# or an int type, then we know that it ranges from negative 2 billion and something to positive 2 billion and something. So there are cutoffs. All of these are restrictions. I can't have Bob as an integer, no matter how much Bob wants to be an integer. Will never be. Why do we want types? Well, let's talk about a language that's a little loose with types, JavaScript. This comes from a presentation at CodeMash 2012 called WAT. It's a lightning talk, hilarious. I have a link to it. Definitely watch it afterwards. And during this point, the presenter says, hey, let's create an array in JavaScript. So we have a 16-part array, and it's represented as just a bunch of commas, empty strings and commas. So we're going to join WAT to that, and now I get WAT 16 times as a string. And you might ask, well, if you add 1 to WAT, what do you get? And the answer, of course, is WAT1, because the 1 ends up getting coerced to a string. So you say, well, what happens if you subtract 1? And the answer is technically correct. It is not a number. WAT minus 1 is not a number. I don't know that that's useful for people. Nevertheless, it is then apparently coerced into a string because you can then combine it with a string. So this is what happens when your types are trying to be friendly. You end up getting yourself into holes or hilarious 1960s memes. So in C#, going away from JavaScript, let's go to languages that have a reasonable-ish type system. C#, we're used to defining types. Int x equals 6. Sometimes we say, I don't need to define a type. Var x equals 6. So I have a variable. You know what, compiler? Look, I paid you a lot of money. You figure it out for me. On the F# side, we're used to not defining types. So I'll let x equal 6 and say, you know what, compiler? I didn't actually pay you a dime, but still you're going to figure it out for me. Sometimes I need to define that, yeah, actually, this is a real type. It is an int. So I'm going to define x as an integer using this format. I'm going to change it to blue for slides. And we'll say x is an integer, define it as a value being 6. Next thing I want to talk about is option types. Now, let's zoom in on this because I'm sure that nobody in here has ever gotten a screen that looks like this. It's talked about object reference not set to an instance of an object. As a casual, I get this occasionally. Nobody else in here does. Nobody's going to raise their hand and say they get it. So let's talk about why I get this. This is a null pointer exception. I tried to reference something in an object that is actually null. So it's null, it doesn't have the thing. We try to dereference that, we try to do something with it, and we get this pretty yellow screen that blows up and gives us all kinds of bad information. So how do we fix that? The obvious answer is we get rid of null. Just eliminate null altogether, and then you don't have null pointer exceptions. And I say that as a joke, like 10% joke. It's 90% serious. The way we get rid of null is through the option type. So F# has this concept of an option type where it may be either some value or none. So none is not null. None is appropriately defined. It is well defined. But if you have something, it is some value, some integer 6, some string Bob. It exists, and we can work off of it. And with that, let's jump to the first set of demos. So here we go. In the console, I've got Visual Studio. I have the F# interactive console. I'm actually going to reset this so that we start from ground 0. And we have basic types. So I can define like integers and strings, decimals, and floats. One thing I want to point out, F# does not allow for implicit conversions. All conversions, you're going to make them explicit. So decimal, I can't say 0.86 because 0.86 is actually a float. 0.86 m is a decimal. And if I don't include the m, the compiler gets very angry with me and says, I don't know why you're trying to mess me up. Actually, I need to do it below because here it doesn't get angry with me, but what it says is, oh, you may call it a decimal, but it's really a float. So if I have a case where I want to coerce a variable or a value, I have some other int that I've defined as 8, some other decimal. Here, however, if I remove this and I try to save it and I try to run it, I will get an exception that says, look, you were supposed to give me a decimal. You promised me a decimal. You promised me a pony, but you gave me that instead. That's not a decimal. The only way it's a decimal is if you give me an m at the end. As far as options go, I can define some integer as an option. So this will be 6, and it is sum 6. And we can see the output, sum 6. I can also define an integer as an option and say, I have no value. This is not an integer. This is none. So it has no value. I can create a function that checks to see, do we have a value? We have a question.
So it's an uninitialized variable?
So the question is this an uninitialized variable? The answer is no. The reason is this is not a variable. No int is a value. Once this is set, it's not mutable, so it doesn't vary. Sounds like I'm just playing semantic word games, but there was a significant difference. If it were to be a variable, I would have to define this as mutable, and then now it's a variable, and even then, it's still initialized. Its value is none, which is different from null, because null is unknown. It's, well, you know, that hasn't been resolved yet. None is, no, you don't have a value. You may have one later. You can come talk to me later and maybe I'll change my mind, but right now, you have no value. So I have a function, has value. It's going to take in some input I. We're going to do pattern matching, like a case statement, but a little bit different. Basically, we match our input I and ask, do you have some value? If you have some value, return true. And I have an underscore. That underscore represents the concept that I frankly don't care what your value is. I'm not using it. I'm not going to need it here. So instead of even giving it the dignity of a name, I have dumped it off into underscore and said, you have no name. Your existence is merely perfunctual. Yes?
So in your optional int declaration where you declare it as an int option, do you have to include some with the value?
Great question. Do you need to include some with the value? And the answer is absolutely. So if I say other int, which is an int option, and I try to set it to 6, it's going to give me a hard error and say, look, you told me that you're expecting an option, but you gave me something that's not an option. The only way that this can be an option is if it is either some with a value or if it is none. So again, you cannot implicitly convert from the land of integers to the land of optional integers, because if you could, I might be able to send you something like a null, and then things get really wacky. And the whole point of this is to avoid having the concept, the possibility of a null. So being safe from the ground up. So,
Visual Studio 2019 has started suggesting using underscore for something that's very similar to this. Is that the same thing? Does anybody know?
in C Sharp?
In C Sharp.
So apparently Visual Studio 2019 is suggesting underscores for values that you don't care about. It probably is the same.
That's a feature of the latest C Sharp.
Oh, is it C Sharp 8 thing?
It's
Okay.
a C Sharp, a 7.2 thing, they're called discards.
7.2 you said?
7.2 is.
Okay.
Is that exactly what he said? It's a discarded value. I don't care.
Yeah. So
Keep straight, sorry, Dan. How does that keep straight from private variables?
so the question is, how does this differ from a private variable? And private variables have names, you care about them, you reference them, and you're going to probably use them later. This underscore, this discard, I don't care about it. I need it. I need it structurally. I need it to exist, but I don't care what it is, and I don't care what you do with it, because all I needed to know was the shell is here. There is some value. What that value is, who cares? Throw it away. So this is explicitly telling the developer, you're not going to need it. You don't need to know what the value is. Just throw it away. All right, so I'm creating my function. I have a function, has a value. What is really nice is the signature of this function. It is not going from, say, an int option like I defined. It is an a option. So that thing says it's totally generic. It's like a T in C Sharp, where it's truly generic. I have the one function that handles everything, but I don't have to bracket T everywhere. So okay, let's use that thing. We have a function call. So we're checking to see, does optional int have a value? And it does. Does noInt have a value? And it does not. So true and false. Now let's create another function and not fill out this pattern. We have bad has value, where we're matching I with some value. And if we have some value, return true. The compiler is popping up this little warning. Incomplete pattern matches. What the warning is telling us is, hey dummy, you realize that if somebody sends you none, your function's going to blow up.
Good check.
It is a really good check. The F# compiler is really smart about warnings. Whereas in a lot of languages, I remember C++ compilers would just spit out warnings all day, and even though it's perfectly adequate code, this compiler, usually if there's a warning, there's a reason. Says a guy who is awful at C++. So bad has value. If we pass in some value, it works. So we have our unit test, we can ship it. And then we go out into production, and it turns out that we kind of forgot about this case. And then it gives us an exception, a match failure exception. And that's not nice. But the compiler did tell us that that's exactly what was going to happen. So pay attention to the compiler. Another function. So I want to get driver's license. We're issuing driver's license. And in fact, I could even call that issue if you wanted to. But given your age, if you're at least 16 years of age, then I'll give you some driver's license. I'll give you a driver's license. Otherwise, you don't get a driver's license. So we create the function, and the point here is to say, I can take something that is not optional. That age is not optional. It's just a regular int. And I can generate an option from it using this pattern matching.
Does it derive age because you're comparing it to greater than equal to a number, an integer, or was age defined above?
So how does it figure out that age is in fact an integer? And the answer is it is in its usage. If I change this to 16m, then age becomes a decimal. So if it can figure out based on usage that you need something specific, it will give that specific type. Otherwise, it can be just a generic type, an A. And then you can pass in whatever you want. And as long as that property exists, go for it. But here it knows this must be an integer. So,
And if you don't have a none there, it will show you the same error.
if you do not have a none, will it show you the same error? And the answer is, let's find out. The answer is yes. Yes, it will. Because here, it's not so much that it's a none. It's that you're missing a false. So let's walk through. For example, the value false may be a case. So if you have a string and you're trying to match on a string, it'll say, oh, well, it'll find a case, such as, let's say you're looking for the strings 1 through 9, because you're accepting input as a string. And it'll say, wait, what if somebody types in an A? You've looked for the cases 1 through 9, but anything that's not one of these then can blow up, unless you have some catch-all, which looks like that, where it's catching everything else. In other words, I don't care what it is. In this case, because Boolean only has a true or a false, I actually get a warning that says, you're not going to fall into this case. It's logically impossible, so why do it? But if I had a ternary case where it could be true, false, or file not found, then I could do an underscore and handle file not found and the fourth case that gets added to Boolean logic. Super Boolean version 3.0. So, okay, I get a driver's license. I'm 21 years old. I swear, don't ignore the gray hairs. And I get some driver's license back. Turns out I'm actually 15 and none. So a 15-year-old doesn't get a driver's license, 21-year-old does. And we ask, okay, how can we use this? Well, match doesn't have to return an option either. So I can take something that is an option, unwrap that option, handle the value if it exists, and then return back something that is not an option. So I'm going to try to enter a bar. And of course, there's a bouncer who wants to see a driver's license. If you have a driver's license, you just need some driver's license. Then we're going to call a sidle-up function. Sidle-up takes a driver's license and does something. You sit down at the bar and do whatever you need to. So if you have some driver's license, you get to go to the bar. Otherwise, bouncer says, go away, kid. So here, we're matching on the patterns on some and on none. I actually do need that value for the driver's license because I'm passing it to another function. So therefore, I can't make this an underscore. First person, who's 21, tries to enter the bar. We do something. Hooray. Second person tries to enter the bar, gets sent away. So those are option types. That's how we get away from the idea of null. It's how we are forced to handle those branching paths that you don't want to think about because it's not the happy path. So pattern matching forces us to get through, well, what happens if I send you something that's really weird? What happens if I send you a string that you're not expecting? Whereas a case statement, if you don't have a default, you can successfully end a case statement without a default and have unexpected behavior if someone just happens to send you something outside of your pattern of expected cases. By the way, if there are any questions, shout them out at any point like you guys have already been doing. So I'm not going to stop at each one of these and say, do you have questions? There's a question, or possibly an extended comment. We'll find out.
We'll find out. I just want to make sure that I'm grasping this. As you were reading down through there, I was thinking to myself, I could mimic this in C# with a normal type of name. Until you got to the compiler checking for missed cases. It seemed like that's, am I correct, that's something that you demonstrated here. I could have done all this in C#, but what I would not have, since it is part of that language, is missing checks, missing cases.
So the question was, what can I not do in C# that I've shown so far? And related to, I can create nullables of type X. There are a couple of things. I think one of them is that even with the nullable, it may be possible to give the nullable the slip and not have a value, if I remember right. So null is still something that can weasel its way in, even if you're trying to work around that with your own custom types. Even in F#, you can still get nulls. So if you're interacting with something that can return null and you're not thinking about it, you can still get a null and you can still blow up on a null pointer exception. This makes it a lot harder. Making nullable of t and working with that nullable of t will certainly get you most of the way there. So I think it gets you most of the way to where you're at with an option. Pattern matching and the compiler being smart enough to recognize missing patterns, that's the part that you're probably not going to get with the C# compiler. So yes. Let's talk now about product types. A product type is a combination of multiple values. So we're going to look at two tonight, tuples and records. Tuples, you get them in C#, you get them in F#. System.value tuple is extremely close to F#'s tuple. In F#, we're going to define a tuple as a comma-separated list. For the reason of clarity, you put parentheses around it because that's what mathematicians do. The compiler interprets it as, instead of commas, asterisks. And the reason is that this is the product of these values. So we have the product of an integer and an integer and an integer and a string. So all four of those combined together form our tuple. And it is a thing. It is not just a collection of things, it is a thing in and of itself as well, which is helpful when you are calling from F# some C# code. So C#, VB.NET, BCL methods only accept one argument. Thinking about it from C# land, you're like, no, that's not at all true because I can have parentheses, argument 1, argument 2, argument 3, argument 4, argument 5. Well, in F# world, I send in a tuple of those arguments. So it kind of looks the same way. Versus a pure F# function, I have a couple of different methods for dealing with arguments. So we'll see this in the demos. Before I get to the demo, though, I want to mention record types, because a record type is a product type. It is still the combination of a set of types, but each one has a label. My reference for development feel for this is like a struct, where it's not exactly a struct, not necessarily, but we don't have methods, we don't have accessors, we don't have mutators, so no methods, no properties. It is just a labeled concatenation of types that are intended to hold data. In other words, really good for databases. C#8 has record types. So they are coming. They will probably be very similar to the F# record types, but I don't know exactly if there are any gaps between the two. Is a record type static in C#? I don't know if it will be static. My guess would be no, but I'm not sure. So let's talk demos. Tuples. So tuples, mentioned, also called product type, or they are an example of product types. And I define a tuple with commas. 1, 2, 3, I now have an x, which is a tuple of int, int, int. An int, and an int, and an int. I don't need the parentheses, but I highly recommend you use the parentheses because it is A, mathematicians use parentheses, and functional programming kind of tries to be as close to mathematical as possible without going over. Sort of like Price is Right. And B, I think it's a lot easier to read your intention with this versus this. Just having the parentheses don't come up very often in F#. So knowing that these parens are here, say, oh, okay, I have a tuple. A tuple can certainly have multiple types, int and a string and a bool and a decimal and a float. It's a tuple. It's a combination of many things. And I'm emphasizing the word and here. So and. This will become very clear in the next section why I am saying and with capital letters. It's a very smart crowd. You've already figured it out. So F-sharp methods use a couple of concepts, currying and partial application. So let's talk about these. Partial application. I have an add function. I'm going to take x and y, and I'm going to add them together. Okay, so our signature is not like x comma y going to an int. Instead, our signature says we have a function that takes x. We are going to operate on it to a function that takes y, and operate on it to give you back an int. That's quite a different pattern. And where it benefits us is in a case like this where I have a partially applied function. So add1 is a function on top of add where I set y equal to 1. This is beneficial. Think of it in when you're writing C# code and you have overloaded methods. So I have a version that takes 8 parameters, a version that takes 6, a version that takes 3, a version that takes 3 other ones. In F#, you're not allowed to do that. Functional programming languages, you're not allowed to do that. You have one function named add. So what we do instead is you partially apply. If I have the 8 inputs and 2 of them are optional and I know what the values should be if you don't give it to me, I can have another version, another function that takes the 6 I need and calls the 8 with the extra 2. Conceptually, you get to about the same point, but instead of overloading a method and potentially running into problems with overloading, problem with overloading being that if I have, say, 8 ints, and I have a version that has 6 ints, I can't have another version with 6 ints that are different. Versus with functions, I could have 2 functions, one that's like this set of 6 ints and another function, this set of 6 ints. So I have a little more flexibility. I'm actually surprised I came up with that one off the top of my head because I didn't even think about how I could compare the two conceptually. So go me. Of course, if I add 1 to 7, the answer is 8, which is an integer. Notice that add did not need a comma, did not need parentheses, did not need anything special. It is 2 separate arguments. But if I try to do this with, say, arctangent, arctan2, in the system.math library, I try to run this, I'm going to get an error that says, I need a float times a float, but you just gave me a float. So what we really need is a tuple. So when you call those C# functions or methods, we need to send in tuples. Unless you have just one input.
And a comma just without the parentheses would also do, right?
So can a comma without parens do? The answer is, in this case, actually no, in this case it needs the parentheses. It's when you're defining a tuple from scratch that you can avoid the parentheses. So that's another reason to use parentheses, because you need them in this case. We can certainly create an F# function, like another, we could change add. So instead of taking in x plus y as 2 separate inputs, we could take in a tuple. And you see how the signature changed? It is now a tuple of x and y that goes to an integer. But then add1 gets a little weird because it's like, hey, you kind of were expecting me to, I guess I could do like that and change it. So as long as I'm still working with tuples, you can still partially apply, but it's more programmatic F# or speaking F# natively, not to use tuples when you don't need tuples. There are cases when you do need them. If you do need them, use them. But it's not like C# where all method calls must have parentheses, must have comma-separated arguments. And here's a little bit of flexibility that we can use by avoiding tuples. So I've got some functions. I'm going to reticulate splines, develop features, and accentuate curves. I just made these up. It's okay. And I'm going to implement a grid pattern. Inside my function to implement a grid pattern, I'm going to have a path builder. So there's this path builder function that takes a y. So we take an x for grid pattern, we take a y for path builder. Inside there, we're going to call accentuate curves on y. We're going to take the result of that and pass it to this function, take the result of that and pass it to this function, take the result of that and multiply by x. So x and y are actually very different things.
What character is that after the y?
So what character is that after the y? The answer is that this is actually the pipe forward operator in F sharp. It is a pipe and then a greater than. But because I am using Fira code, it will turn that into a ligature, which looks pretty. It's a font called Fira code, F-I-R-A-C-O-D-E. So it turns certain character combinations into ligatures, like greater than and equal. You may have noticed earlier, looks really cool instead of just being, you know, like that. There's a few of these. It works for a lot of languages. So certain languages like R will convert that into a proper arrow. It gets fancy. It's cool. So anyhow, I have that path builder function, so I'm going to call it. If I implement grid pattern, I send in an x, because hey, I saw this signature, so I just need to send you an x. Well, if I send you an x, what it gives back is a function. It says implement grid pattern. So it needs another float, and it will give me a float. But I need to fill out the function. So I can, of course, send both x and y at the same time and get my result. Or I can save this function as prep. So now prep is actually a function value. And I can hold on to that function until later. And maybe, perhaps, I'm waiting for a response from somebody that's going to tell me what I can do with this function. Like, send in this value 8.6. So I've made a call to some remote resource. In the meantime, I have this function prepared so that when I'm ready to roll, I'm going to be able to run it and get back exactly the same result. On tuples, I can decompose a tuple. So multi-x, you'll notice I am not using parentheses. That is on purpose. I have defined x1 through x5. And they are now 5 separate values. So I can say, is x1 greater than 3? No, x1 is not greater than 3. I can also say, I only need y1 and y3. I don't need these other 3. So again, I can discard.
Deconstruction?
It is deconstruction, yes.
It is also C#.
That is in C#? Okay.
It is.
Yes, it is. You're right. It's you can do that with value tuple.
Yeah.
Okay.
You can definitely do a deconstructor in C#.
Okay. So we're deconstructing. Thank you. Thank you. I'm now going to use that term as though I knew it the whole time. Now I'm going to call it a destructor just because. So. Yep. I know. Trust me, I've blown up enough C++ code in my life to know destructors are destructive. So let's say I really don't care about 2, 4, and 5. So again, I discard them. You're not going to need it. Future me or whoever maintains my code later on, I only need these 2 values. I don't need the others. So they get thrown away. Record types, labeled product types. I can define a person. Person has these attributes. I define a person named Charlie. So Charlie has a first name and a last name, has an age, and like Scotty's. Notice, I never said anything about person. The word person does not appear in this block of code. The compiler inferred, based on the labels, the combination of labels, that this is in fact a person. What that means is the combination of labels must be complete.
Do they have to be in order?
Do they have to be in order? Let's find out.
First name and last name or something?
Yeah, let's find out with age. I'm going to say they should not need to be in order as long as they are complete because they are labeled.
Oh, I see.
So order doesn't matter. Existence matters. Yep, here we go. Got an error. Hard error. It says, whoa, buddy. you know you need to give me age. And I say, okay, Charlie, tell us your real age. Charlie's 30. And compiler's happy again. So where might I use record types? Well, I already mentioned databases. Here I'm going to load fsharp.data.sql client. Very small micro ORM. Lets me connect connection string to my local SQL Server instance. I have a command provider that will have a SQL query. So I'm going to execute this SQL query where my IATA is whatever input I give. This is the 3-character code that represents an airport. So that is now a class. There is a class that will generate a record type based off of these inputs.
Is that considered parameterizing when you do it that way?
Is that considered parameterization? Yes. So
Is that the F-sharp way to do it, I guess?
is this avoiding, will this avoid SQL injection? Yes. Is this the only way to avoid SQL injection? No, I mean, if it's just within this particular type provider, it's how the operation behaves. But yeah, it is SQL injection safe. So if you had a different type provider, if you had a different way of accessing code, like you used Entity Framework, you're going to use whatever mechanism allows you to access that database safely. So I have a function, getAirport. I'm going to open my SQL Server. So set the connection, open it. I'm going to create a new airport SQL against that connection string. I'm going to execute the query that was generated up here, and I'm going to get back exactly one result. I am very optimistic that you will type in the correct code. If you type in an incorrect code, it's going to get an error. So type the correct one. And then we will return that result. So I get airport SQL for RDU, and it returns back a record whose contents are IATA, which is some RDU, airport, city, state, etc. These are nullable in my database, so the type provider figured out, wait, these are nullable, they can be null. If null is a possibility, I better make this an option. And now, because we have values, I'm going to return some Raleigh as the city. So I can say, so let x equals get airport SQL, and now I can say x dot and use standard dot notation to print out, well, what is city? But remember, this is an option. Yes?
Did you define the airport record type, or was that inferred?
Did I define the airport record type, or was it inferred? It was inferred from this SQL command provider. So I wrote the SQL statement. The compiler executed a background operation to query SQL Server, figure out what those data types are, figure out what the resulting record structure should look like, and at compile time creates a record type available behind the scenes that can fill up that. Follow-up question, yes?
That seems like a whole lot of work. That type provider, is that built into F-sharp or using the NuGet package?
So where did this come from? This comes from a NuGet package, fsharp.data.sql client. fsharp.data is a third-party package maintained by the community that gives you a bunch of type providers, XML, JSON, a few other things.
We would need that.
Yeah. So if you wanted to play around, you would, in fact, install the NuGet package.
That's by Dimitri, right?
Yes, that is the Dimitri's, yes.
Dimitri's. Yeah, we used to work at Sid Place many years ago.
Nice, nice.
Super bright.
It's a small world.
This is more world. It is. And F-sharp special.
Yeah, that's true. Okay, so as I mentioned, we can reference things with dot notation. So I'm going to print out Charlie's first name. I'm going to print a string, %s, and we see Charlie. That's good. I can also, of course, store Charlie's first name as a value, so I can work with that value later on. So there's nothing special about it once you've got the record type defined. It's just similar to, I have a class that has a property. Well, I can take that property value and save it as a variable, and generally we're good. So let's say I define some other person. As I mentioned, the compiler infers, based on structure, what the record type should be. I have some other person, which is exactly the same record type, structure. So Denise, when I create Denise, she is not a person. She is a some other person. The reason is, by default, F# finds the last valid record type definition. So some other person overrides person, and therefore all of these types are some other person. Some other person is not a person. They don't directly compare. If I want to use person and not some other person, I actually have to use the, I can use dot notation, say person dot, and then pick one property. I don't need to pick more than one, so I don't need to define person dot last name and so on, because it's inferred. I can't have a person and a some person in the same record. So Emily is a person.
You also specify the type like you did with int.
So can I also specify the type for a type provider? This is the way that you specify the type. So you would not say try to wrap this in and say it's a person in parens like that.
Is it complaint?
Well, let's find out. Hey, how about that? Apparently you can. I've never done that. I've only done it this way.
Do you have to specify for all properties or just the first one?
So do you have to specify for all properties or just the first one? Just the first one.
Okay.
Because once you have that first one defined, all of the rest follow from the first. Because you can only have one person. So you can't have a person for this property and like a some other person and a yet another person and a dog lover person.
So it has to be the first one, it can't be.
Could it be any of the others? Let's find out. I only do it on the first one, but I'm pretty sure you can do it on any of them. As long as one of them is accepted, then yeah, it inferred that this is in fact a person.
And so for the interference, is it using, I'm guessing it's using the names as well as the types, right?
So for the inference, it's using names as well as types, yes. It's definitely using names. Should be using types as well, yes. All right. I told you, keep in mind, and, because we're going to talk about sum types now. Sum types, in contrast to product types. So product types are and. Sum types are the sum of multiple inputs, which is a really weird way of thinking of it, but mathematicians, category theorists, they're crazy people. Sum types are OR operations. You have an int, or a string, or a decimal, or another int. In F#, this sum type is also called a discriminated union. So we define a thing as one of. It's like XOR, really. So exactly one of the following. It may be a something of type 1, or something else of type 2, or yet another thing of type 3. That's a little, I think, vague. Necessarily vague at the beginning, but we're going to clarify this with some examples in just a moment. Before I get to the demo, though, let's talk about why they're important. The reason is that they're going to help you replace a lot of if-else logic and also try-catch blocks. So we have a web request, and this web request looks a little bit like this. It's not very pretty, but basically, I'm going to get a result, send in some inputs, get a result back. So we're going to define that as a result. Well, if the server blows up in the meantime, we catch an exception, something bad happened, I'm not going to handle it here, I'm just going to throw a new server-side error. Let the calling code figure out what to do with the server-side error. So then, assuming result succeeds, we're going to come down here, check response code. So is the response code successful? Wonderful, let's return the result. Otherwise, we have an invalid response, and we're going to throw a new exception of type invalid response error. That's one way to do it. It's maybe not the prettiest way to do it, but code compiles.
What's the difference between the two types of errors?
So what's the difference between the two types of errors? You mean server-side versus invalid response?
Yeah.
It's a 500 class versus a 400 class. I done screwed up, you done screwed up.
You say that compiles in what language?
This is a C#. I have var.
It's not F#.
No, this is not F sharp. This would not compile in F sharp. So we're starting out in C sharp. It's a C sharp friendly crowd. So I'm showing you this is how a really bad person would program. Hi, I'm a really bad person. And then we're going to bring it over and say, how would a really bad F sharp programmer do it? The answer is like this. So let's call the function getResult. As a quick note, this getResult is a little bit different. It does not throw exceptions. F sharp exceptions are very heavily frowned upon. So we don't do exception-oriented programming. And I know in C sharp it's also generally very frowned upon, and yet still happens. So we send in some inputs to getResult, and we have a result. Now we're going to check the response code. And this response code will be one of three types. Exactly one of three types. Success, failure, or server error. Well, if it's a server error, then we're going to call build server error. And that's going to return our 500 response and say, something happened on our server, try again later. If it's a build failure, or if it's a failure response, we're going to build a failure result and say, oh, you tried to access an invalid resource, or you are not authorized to access my website, and return that to the end user. If it's successful, it's like a 200, we're going to return the result. Show that on our page as a pretty grid, and people will love it. So this is our sum type. It's kind of working with code. This is technically not a sum type, but it's working in the pattern that we would work with sums. Exclusive or, one of these must be true. So let's dig into some examples of that. Here's a shape. Your shape is going to be one of a circle, square, rectangle, or ellipse. So I have a type of shape, and instead of curly braces where I've defined things with labels, I now have a pipe where I've defined things of component types. A circle takes in a float, radius. A square takes in a float, length. A rectangle, length and width. An ellipse, major radius, minor radius. Once I have these, I can say room size is a rectangle. So notice, first of all, that I can run this. Second of all, that it gives me a shape whose shape is rectangle. And these are its parameters. A pipe opening is a circle. So the shape, that is a circle, that has a parameter of 0.375. Well, with the shape, I can perform an action across different components of the shape. So let's create a function that finds the area of a shape. Depending on what type of shape you have, the formula for defining area will differ. A circle is pi r squared. An ellipse is pi times the major radius times the minor radius. A rectangle is length times width. A square is length times length. So depending on what we need to do, what type comes in, we generate the formula, we send out a response. I don't need 4 separate functions or for each class to have a method that is getArea and then implement the method in each one. Here instead we just have a common function for that more generic sum type and say, okay, well, I can accept whatever type you are because it is a closed space. We're not going to suddenly throw in here like an oblong spheroid because first of all, this is area. You might want to do volume for that. But secondly, there's no second. Really, it was just the one. Just the one. This is a enclosed space. We know what the types can be. If we need a new type later, then I can say, I don't even know exactly what the formula would be for an oblong spheroid, but we have this new type, and our shape area says, hey, if some dummy who just typed this thing in doesn't finish filling this out, and someone actually creates an oblong spheroid in the future, thing's going to blow up, buddy. So very helpful. The discriminated union here basically says you want to handle all of the potential elements of that union.
Would that show up in your output or your error list?
So would that show up in the error list? Yes. If this were an F# a library or console application, it definitely would. Even in here with these scripts, it will show up. So we can see a couple of them from earlier code as well. So yeah, they'll show up down there. They are just proper warnings like any other warning in Visual Studio. Okay, so find shape area given room size. Well, we know room size is a rectangle. So its area is 253. The area of pipe opening, we know is a circle, so its area is this. I can combine discriminated unions. So I have colors, red, blue, and green. So I define that my curtain colors are red, and I'm going to define an attribute. And you can tell me either it has a shape or it has a color, but it can't have both. So
What prevents it from having both?
So the question is, what prevents this from having both? And the answer is that it's in the definition of that this is A or B. So it's not an inclusive or, it's an exclusive or. When you define an attribute, yeah, so basically attribute dot, well, dot, there we go. And with dot notation, I can define color or shape. I can't give you both at the same time. I can create a new thing that has a shape and a new thing that has a color, but they're not the same thing. I can't have both properties on the same thing. If I want both, now I have a record type and I have and.
Okay.
So we have curtain colors, attribute dot color, and my attribute is the color red. Like, okay, that's cool.
Can you show the syntax difference between the two different types? So that one can only have one of the two. What's the other one that's the and?
Oh,
What's the or?
yep, so the record type, or the tuple. So the record type, the type definition was what we were just going through. Looks like this.
It's missing the bar.
Yeah, so the bar, which is pipe operator or, here we have braces that says this is a thing, and within the thing we're separating it with semicolons. Okay, so I want to make shape better. So I'm going to create new types. In fact, I could have just scrolled down to this, because these are product types. So instead of just a tuple of float times float, I'm now telling you this is a float whose name is major radius and a float whose name is minor radius. Quite helpful because the major radius is necessarily equal to or larger than the minor radius. Otherwise, it wouldn't be major. So if I assume that everybody will know that the first one is the major radius, and someone happens to pass in the major as the second because it was just float times float, maybe my code works, maybe it blows up. Here, I at least have a fighting chance that someone's going to look at it and say, oh, well, I'm sending you the wrong one. Or length times width. So now we have a type that is a better shape. It is now a new discriminated union. It is not the same as shape, but is a circle of that product type circle, a square of that product type square. And therefore, I can create an ellipse whose values are major radius 14.8, minor radius 6.7. And I can create a function that accepts this and now explains to you that, oh, yeah, pi radius squared. If you don't have me telling you that the r there represents radius, or that r1 is major radius and r2 is minor radius, now I think this function helps you out understanding what this code represents a lot better than the first one. So we've combined product types within a sum type. And we can combine sum types within a product type as well. So within my definition, say of rectangle, maybe I have a length or another type of thing. Or alternatively, we have a person, and the person has pets, and the pet could be a dog or a cat or a rattlesnake. So that would be a type of pet. It has a name. Cat's got a name. How many times it bit a person? So we're going to make that an int. So now I can have, I'll make type person2. Coding on the fly. There we go. So now person2 has all this stuff, and I can say come on. I need to indent this so that it is happy. Person 2 dot first name, last name, and favorite pet equals, let's say, rattlesnake, who's bitten 6 people. So now, Emily's got a rattlesnake. So here I've handled the other method, where I've got, within a product type, I've defined a discriminated union. So it goes both ways.
Why do you have,
If you were going to have a no pet option, would you do that as within pet or within person?
So if you wanted to have, oh, actually, let me come up here. I'm going to save this for uploading code later. So what if you wanted to have no pet? Well, let's say Frank doesn't have a favorite pet. Frank is kind of, but notice that Emily fails because rattlesnake actually needs to be some rattlesnake. Yeah, because Emily has a pet. Actually, I have to redefine type 2 before I can run these. So Emily has a pet. It is a rattlesnake, so she has some pet. Frank has no pet. He has none. He loves all of his pets equally.
That's what you were showing way at the beginning.
Yep, before you came in.
Gotcha.
Haha.
So
Oh.
why is that? And also maybe I'll also give a little like, why do you have to say some? Why can't it, like if you specify a pet, I mean,
So
it kind of imply that there's a pet.
why can you not just say rattlesnake 6? And the answer is rattlesnake, or let's just say it's an int. It's easier to say it as an int. So I have an optional int. The optional int either has a value or it doesn't have a value. This is a wrapper that is going to protect me from accidentally sending a null. Because, well, with the rattlesnake, I might pass in null. Sum is our way of getting into that option. There is no implicit conversion. So I cannot implicitly convert from a rattlesnake to an option rattlesnake. I have to define this is an option. I know I have a value. I've got a value, I promise. If I don't have a value, I have to tell you none. I have to tell you I have no value. So in both of these cases, I'm sending you back an option. If I didn't, if I just sent you the rattlesnake, then either I'm not sending an option or I'm expecting implicit conversion. And implicit conversion is where we get hidden bugs down the road that we don't expect.
And there's a difference between none and null.
So there is a difference between none and null. None exists. None is a thing. And also, none doesn't have properties on it. So if you have null, you know, in C# land, we might say x equals null because, so some cool class x equals null. I've defined it as null, and there's some code, and I'm going to instantiate, you know, x equals get something. And then I'm going to say x dot some property, but I misspelled it because it happens in life. Well, at this point, we get a null reference exception. C# code, this will compile, run perfectly. The compiler says, nah, you're fine. Everything's good. even though you told it at the very beginning, it's actually going to be null. But the assumption is that get something will give you back something other than null. If it doesn't, boom, you blow up. By contrast, let x is an int option equals none. Let y int option equals sum 6. Y dot, so we have is none is some value, and we have things off of it. Let's see what we get off of x. Because x is none. Oh, turns out that with the option we actually will get the same thing. We're going to get x dot value, which will blow up on us. Check that out. Null reference exception. But you don't want to do this in F#. You don't want to call dot value because you don't know if somebody's going to send you a none. It's the same thing as you don't start dereferencing objects in C# if you think that they can be nullable. The risk is sometimes you don't know if it's going to be null. And if it's like 3 extra lines of code to protect against null, so we rarely do it. Until it blows up, then you add those 3 extra lines for that one case. But you don't do it for the other 9,000 cases because that's 3,000. That's 3 lines per E.
That's just silly.
Yes. Any other questions before I go on? Okay, so let's talk about the unit type. The unit type is a representation of a category with a single element. We're not going to talk category theory tonight. You're welcome. So let me rephrase this in a way that is not heavily mathematical. Values go here to die. It is a sync node. You can take anything and turn it into unit, but you cannot get anything out of unit. Unit is essentially a way of saying, I have a value, it exists, it is a thing. This is not null. It is a thing, I just don't care what it is. I can't make use of it. The benefit of this comes from working with expressions versus statements. So I have an expression. An expression has inputs, does stuff, an input does stuff, gives me an output. Well, unit guarantees that every expression returns a value. That value may not be useful to you. So you may have a function whose job is to print out to the console. My expression needs to return something. Printing out to the console is a side effect. It is not the end result. It is not the output. It is just something that happens. My side effect is the intention. So that is the thing I care most about, but I still need an output. I can output unit. Unit is my way of saying it's an output. We're not going to know what it is. We're not going to care what it is. C# does not have a unit type. In fact, I think this is the second biggest mistake in C#. Biggest mistake is null. Second biggest mistake, there is no unit type. Therefore, void and non-void are totally different. Void has no operators. You cannot operate on void. It is entirely different from non-void. Non-void, you can operate on non-void things. With void, you can't operate at all. I have a link to a Stack Overflow answer from Eric Lippert where he talks about some of the ramifications of this. And we'll also say that this is why we have actions and we have funcs in async in C#. And you cannot have a single method that is doesn't care whether you give it an action or a func. Actions behave in a certain way, funcs behave in a certain way, and you can't really mix the two like you could if there were a unit type. If there were a unit type, everything's a func. You don't have to worry about the difference. So with that said, let's go into our demo. Unit, I'm going to create a function called print something. So my input is this S. S is actually not a string. It is apparently a text writer format of unit. But then we print to the console that thing, and then we print out, we return its value as our output. So print something, print this is a test, and what we're going to do, look at that, I popped myself into full screen mode. Only like 1 hour into the talk. Result is a string. This is a test. The console had this side effect where we wrote, this is a test. So I have a result. But what if I really don't care about this result? Yeah, I mean, I can use it, but I've already written that out. I don't need it anymore. So I can ignore it in one of two ways. First, I can just call print something. And it writes out to the console. And it does technically pull back in a string. The F# interactive has this inbuilt value called it, where it is the it's like the back-end catcher for anything that you let loose. So that's why I can simply say res, and it's like, oh, okay, well, res is going to output the string, and it will be caught by it and then written to the console. If I have a regular F# application, I don't have this F# interactive capability, and what will happen is I'll actually get a warning here, because the compiler will say, you know, the whole point of an expression is to take an input, do something, and give an output. You have given an input. You are doing something, but you don't even accept the output. Perhaps you are new to this programming thing. The compiler is a huge jerk. In this case, I could tell the compiler, no, sir, I am not new. I am just bad at this job. But I don't care about the result of print something. So therefore, I am going to ignore that warning. Or you can do it the better way and say, you are correct, sir. I am going to take something, its result, and I'm going to send it to a function called ignore. Ignore has a nice definition. So ignore takes in anything. In this case, it is a string. And it will give you back a unit. So now we return the unit expression. Well, the compiler is smart enough to recognize you can't operate on unit. You can't do anything with it. So if I do not handle a unit, then the compiler it understands that I can't do anything with it, and therefore I can ignore it safely. So by piping this to ignore, I tell the compiler, I understand what I am doing here, so get off my back. You're not my real dad. Yes?
So question, talking about, this is an expression, right?
This is an expression. Yes, it is.
So, I remember what you said earlier, an expression is a pure function?
So, is an expression a pure function or vice versa? The answer is that expressions do not need to be pure. Pure functions do need to be expressions. So a pure function has an input, does stuff, has an output, has no side effects in between. I can certainly have an expression like print something where I have a side effect. So I took my input, I did something with it, I got an output, but I have a side effect in the middle. That's the difference.
So, because pure functions have no side effects, right?
Pure functions have no side effects. That is correct. And if you want to see a unit in the wild, it's just empty parentheses. So that is how I define unit. So I can have a function. And I can say, don't do anything. Give me an x. I'm just not going to do anything with it. Let it die off. So I can call a really cool function. And x, by the way, is anything. So you can see it's defined as literally anything. I can pass anything I want to it. In fact, we could call this thing ignore. We've just defined the ignore function. How about that? Any questions on?
So is the name X or reserved word, keyword, is it?
Nope. Yeah. Thank you. Thank you, Stream Engineer. Is X special? No, X is not special in any way. And the answer is just our label. Yeah, so it's still a value, still of any type at all. In fact,
Could you have used the underscore at that point?
so can you simply define this with an underscore? Yeah, underscore arg1.
Okay.
So I can say, ignore. I don't even care about it. It's probably even better to define it with the underscore. Like,
But isn't the ignore function special? You're just override it?
is the ignore function special, and am I overriding it here? It is a core operator, but this is effectively what the ignore function is. So I'm not going to execute this, but yeah, I could certainly say my ignore. But basically, that's what ignore is doing. It's not doing anything else in addition to that. Custom types. Here's where we get into some fun stuff. So sometimes our built-in types are a little lax. Like, we have a set of integers. So I have a list that has integers that are supposed to represent prime numbers. I have a class, int, so integer class, but 4 is a valid integer. 4 can fit into a list, but if it's supposed to be a list of prime numbers, 4 is not a prime number, should not be in there. If I want to protect my list, say only prime numbers get in here, I could create a class, prime number, and have in its constructor, you take the int, so make it a forced constructor where you give me an integer and I figure out whether it's prime, and if it is prime, then I will allow it to go into this list. So I have a list of prime numbers as opposed to a list of ints. I could do this in C#, absolutely. It is a little bit extra code and gets a little annoying. F# has something similar. So what we're doing is narrowing the range of acceptable values further than what the raw type will allow. So types themselves are just narrowing their restrictions. Here we're restricting further and ensuring that at compile time, we're not going to break this. Or rather, we are going to break it if we try to send in something that's wrong. So where can that possibly go wrong? Well, suppose, now nobody's done this in here, I know, except for me, I've done this. Suppose you have a method, do something, that takes in 2 integers, x and y, and then we call do something later on and accidentally send in y and x, send them in the wrong order. If you're lucky, the relevant domains for x and y are so different that it'll get caught and you'll get an exception, or you'll get a response code that says this is an error. If you're unlucky, you will have bad data in your database because you accidentally put somebody's age in where it should be number of children, and vice versa.
Or height of weight in centimeters and kilograms, something like that.
So height versus weight in centimeters versus kilograms, and yes, similar, but we have another thing for that specific scenario that we'll talk about in a little bit. But yeah, that's general concept. If you define them both as the same type, you can't prevent flip-flopping.
Well, I've encountered this in one of my customers' databases where they typed in the fields in the wrong order.
Right.
And that was the general rule was one was always greater than the other.
I've seen some pretty big people. Yeah, no, that's a fair point that you can have rules, and that's more of end user data collection. This is more of developer makes a mistake problem. End users are still going to put in bad data no matter what you do. Custom types will help you restrict the range of bad data that they can put in, but end users are very creative in corrupting your data. So if we created a custom class called customer ID and a custom class called product ID, and we defined X as a customer ID and Y as a product ID, even if they were both integers, by creating these 2 classes, I can say X and Y. Now I can't accidentally flip them. I can't call do something with Y comma X because I will get a compile time error. That's great. The difficulty is creating a class for every possible field it's a lot of pain. So let's see how we do it in F#. The answer is it's still a lot of pain, but useful. So I've got a slice of code here that is called railway-oriented programming. I'm not going to get much into this tonight. It is a whole nother talk, trust me. But think of it this way. We have a sum type, a result, and that is a result of your success case and some messages. So if you succeed, you have a success and 0 or more messages. If you fail, you have a failure and 0 or more messages. So you don't have that success output. T success is a type. It could be a string, an int, it could be a class. Go hit the database, pull back in your person. Well, now T success is person. If you fail to collect the person, can't find the person, for example, or database error, you now have a failure. You define why it's a failure. So that's our 2 tracks, success and failure. Now I have another type, sum type, integer errors. So I'm working with a couple of integers. What kinds of errors can I have when working with an integer? Well, you may not send me an integer. In that case, it's missing, it fails. If I can accept any integer from 0 to whatever the max value of int is, or to infinity if I'm in idealistic world, then those are whole numbers. So if my customer ID must be a whole number, it means I can allow 0. If I don't allow 0, those are natural numbers. So I've defined those types of integer errors. Then I can create a module, a profile ID module, that has some integer that we're going to call t. So t is the name of it. It is of type profile ID event. And in the create function for it, we take in an int, I, and we check to see if it's less than 1, I fail, because it must be a natural number. I can't accept 0. I can't accept less than 0. It's got to be greater than 0. If it is greater than 0, I succeed and give you back a profile ID. So this custom type of profile ID. I'm going to do the same thing for a customer ID, which is also an int. So let me just run these. The rest of the functionality is useful for railway-oriented programming, but trust me, tonight is not the night for that. Product ID is a long int64. So you give me an int64, and again, it must be a whole number. I do have to call this an L. All right, so we have our checks, and I'm going to create PID, profile ID.create 1, 2, 3, 4, 5. It succeeded, so it gave me back the type of success. The successful result object is a ID whose value is 1, 2, 3, 4, 5, and I have no messages to look at. If I try to create a profile that is negative, I will get back a failure, so that is my result, versus a success, and I get the list of messages of why I failed. I can, of course, do the same thing with customer, and you'll get answers. Product, I can create a product. Notice that I need the L. So you may say, but wait, that works just fine in C#. But again, implicit conversion, not friendly here. You need an int64. You provided an int. Therefore, kaboom. And you say, okay, boom, there's your int64. It says, ha, very funny. First of all, son, int64 is not this. Second of all, son, that's outside the range of 32-bit integer. So you failed even in sending me an integer. Yeah, it's very, very demanding. So, however, if I could say, give me the long string of 8s. Drop an L in there. And now it says, it's pretty big. It's a lot of 8s. So that was outside the range of 64-bit integers. There we go. That's inside the range. Or I'll just drop a few more 8s off. Okay, so now we have a product ID. We've fought the compiler. Incoming profile. I got this in from the database, or I got this in from some C# code. So it is an int. It is of type int. Now I want to upcast it. I want to take it out from the muck of ints and bring it up to the glorious world of profile IDs, if it is successful. At this point, we don't know that it's going to succeed. So we need to call the create function, send in that incoming profile, and we get back a success because it passed our rules. So now we have profile ID. It is high up on the mountain. This is safe. I can work with this as a profile ID. I know that it is guaranteed to be a valid profile ID because it can't be negative. If I can have all kinds of other rules around it. I could have a lookup against a hash table or a database to ensure that it is a valid customer. I can ensure that it is an active customer. I can ensure that whatever criteria I need to meet to be up on the mountain. So I define that. Or my business users define it and I implement it, if you want to go that way. So now I have a function, handle customer. So we send in a profile and a customer. Notice that I use the .t. So this is the thing inside of my profile ID. Profile ID itself, recall, is actually a result type, success or failure. That result type has a profile ID.t and an integer error, which is the list of messages. So I want the .t. The .t is a discriminated union. It's a sum type of just one thing. It's got to be an int. So this thing is an integer, but it is a secure, safe, up on the mountain, everybody's happy integer, specifically for profiles. This one, secure, safe, everyone's happy of customer. Different thing, different strokes. Now I want to crack open that result message and get to the GUI insides. I want to get to that .t. So I'll have a function. This is not the real way to do it, but this is the way I'm going to do it tonight because I don't have time to explain the real way. So what I'm going to do, you gave me success. Fine, I'll give you back a result. I don't want to handle the failure case because I don't want this to be an option. I just want the result. This is not how we would really do it. And the compiler warns us and says, you're going to be a dummy. Going to be a dummy. But tonight we will not be dummies. For tonight I have seeded the code with correct values. We send this to production, then we'll be dummies. So we extract the value for the profile ID, and now I have PID-T, which is of type profile ID.t. So it is no longer a success. We're still up on the mountain. We have still successfully achieved our goal, which was to ensure that our profile is a valid profile. Our customer is a valid customer. And then I can call handle customer, passing in our profile and customer, and I get back the results. If I try to do it the other way around, I'll get a hard compile time error on both of these. So the first one says, I wanted a profile, but you gave me a customer. The second one says, I wanted a customer, but you gave me a profile. So it doesn't fail on the first one and just give up. It fails on all of them so that you have to fix all of them. Now, suppose I'm taking this from my F# system, which understands and handles the concept of this custom type, and I'm going to send it over to the application over here in C#. Well, C# not going to be able to handle this custom type. So I need to bring it back down from the mountain, throw it into the muck of integers, all integers, and then shove it over to C# or shove it into the database, shoving it someplace. To do that, I can explicitly cast as an int, saying int space PID-T. So int, oops, gives me back an integer. Int of 8L gives me back an integer of 8. Of course, as you would expect, if I try to give you too much, it's going to blow up. So I do the same thing with a client ID, or customer ID, excuse me, and now I can use those as regular integers. I do this at the edges of my program. Within my program, I want to have that safe value. I want to have the profile ID and the customer ID and the product ID. But then as I exit my program, as I exit the boundaries of my domain, I have to convert for the sake of integration. Questions here? Is everybody just waiting until I flip over the slides before asking questions? Because that's a valid strategy as well. All right, units of measure, last piece for tonight. You don't get these in C#. These are F# compiler only. They are compile time only. They are not runtime. They will prevent you from making units-based mistakes at compile time. I can define a measure, define how I convert between the measures. If I have the same unit, I can add and subtract values. So if I have feet and inches, I cannot add 3 feet plus 6 inches. As humans, we can do that because we convert in our brains. The compiler does not. It says, nope, feet and inches are not the same thing. Even if we define a conversion measure, a conversion factor, 1 foot equals 12 inches, it will not allow us to add implicitly. We must explicitly convert to the same unit. Multiply and divide, you can use different units. 8 meters per second. We can solve physics problems. So, classic physics problem, train heading east at so many miles per hour, train heading west from the opposite direction, so many miles per hour. At what point do the trains meet? Possibly collide, because you only built one track. I'm like, okay, I solved these types of physics problems, but I actually had a really cool teacher in high school, physics. This is the type of problem that we solved. Randy Johnson once exploded a bird during a spring training game. This was in 1997, as I recall. So I actually had a physics problem about this. The question is, since Randy Johnson throws a pretty mean fastball, or threw at least, how long did this bird have to survive? We're going to find out. So let's get to our demo. Let's talk about units. Here are the units of measure that I will define. Inches and feet and miles for distance, seconds, minutes, and hours for time. I can define conversion constants, so inches per feet, feet per mile, seconds per minute, etc. I don't have to define just this set. I could, of course, have inches per mile and seconds per hour. So I could have overlapping sets, but I figured if I have the bare minimum, that's good enough. So I define a time, 7,240 seconds. Using angle brackets, that is a time. Or actually, technically, as far as the compiler is concerned, that is a value. It is a float of type of unit of measure s. And some human can figure out what s means. So compiler doesn't know that this is actually a time. The compiler just cares that it's a unit of measure s. So I can convert time to hours by taking time, which is a float of measure s, dividing by seconds per minute. So 90 seconds, and divide by 60 seconds per minute. So 60 seconds per minute. Those two s's cancel out. The minute comes up to the top, so I have 9/6 minutes. And then I can take that to hours using the same type of conversion. Oh, there we go. 2.01 hours is 7,240 seconds, in case you were interested. And notice that the unit type changed from seconds to hours. So Randy Johnson, we're going to assume that he threw that fastball at 98 miles an hour. He was good for at least 100, but it's spring training. He's just warming up. The bird was about 50 feet from Johnson, because you have 60 feet 6 inches to the plate, but he was a big man, 6'11", 6'10" at least. Oh yeah, he was huge. So by the time he's done, by the time the ball is released, he's at least 6 feet or so up. And the bird was not at the plate, a little bit in front of the plate. Long way of saying, we're just going to say 50 feet. he threw at 98 miles per hour. The question is, how much time did the bird have to react and to move? So at 50 feet, 98 miles per hour, we need to take this miles per hour, so pitch velocity, multiply it to get feet from miles. We have hours, so I need to get minutes, and I need to get seconds. So doing all of that, I have 143.73 feet per second. That's how fast that pitch was, converting miles per hour to feet per second. So then I say time is distance, feet, divided by feet per second. In other words, the bird had about a third of a second to recognize that a fastball was coming its way before it went poof. That's not a very long time. So we.
How far away was the popcorn?
How far away was the popcorn? That's a good question. It was spring training, so they're not in full game shape where they're running up and down the stairs selling popcorn. Oh, I see what you mean. I see.
Distracted.
Yeah. No, they just flew across it. It's I think that was in Florida. So just a bird. I don't remember what type of bird it was. So anyhow, we have a length, 8 inches. We have a width, 1.1 feet. A circumference is just length plus width quantity times 2. But I can't multiply these together because I'm not allowed to combine a foot with an inch. No implicit conversions. I need to explicitly convert using inches per feet. So even though I've defined a conversion function, the compiler will not implicitly convert. It will force me to be explicit. I can multiply these together. Area is length times width. So I have a length, I have a width, and I run this, and it says you have 8.8 foot inches. That's technically correct, but it doesn't make any sense. So we need to convert width from feet to inches, or I could convert from inches to feet. We end up with 105 inches squared. So 105 square inches. That sounds more correct. Of course, we're going to talk about degrees Fahrenheit versus Celsius. So I have a function that converts. Given degrees centigrade, we're going to convert to Fahrenheit. So C is our input. We take C, we multiply by 1.8 times degree Fahrenheit divided by degree Celsius, and add 32 degrees Fahrenheit. So notice I did not define a type of Fahrenheit over Celsius. Instead, we're able to use in our units meters per second squared, or degrees Fahrenheit per degree Celsius. That also means that C must be degrees Celsius, because if I'm going to add degrees Fahrenheit and I have this conversion function, I need to get rid of the degrees Celsius. So the only way I can do that is to have degrees Celsius. So the compiler is pretty smart about this stuff. And it will allow me to convert 0.0 degrees Celsius and get back 32 degrees Fahrenheit. If I try to send in a unitless function, I have no measure, I have no unit of measure, it will give me an error and say, you have sent me a naked float. I require a float that has adornment of this sort of measure. Therefore, I will fail you. Try again later. Yes?
You've got a squiggly line under the 13.8. Is that
Yep.
because if you get you could have division by 0?
So the question was, why the squiggly line? The answer is, so in my error, I actually got an error here. The compiler was telling me beforehand that, buddy, if you try this, you're going to get an error. And the error is, you need to have the unit of measure. I can't just take a number and assume that it is a unit of measure that I'm expecting. No implicit conversions allowed. I have to be very explicit in what I'm doing.
Got to cast it.
Yep. That way, you cannot send me 13.8 degrees Fahrenheit into this function on accident, and I'll think that it's 13.8 degrees Celsius. Similarly, if I just send you a unit that's right out, same thing. Like, yeah, you gave me a unit, but it's an inch. I'm expecting degrees Celsius. That's not the same. So those just won't work. I can eliminate measures. So again, if I'm going from F sharp to C sharp, where I can't use the unit of measure, I can divide by 1.0 inches. And now I've gone from a height that has a unit to a height that doesn't have a unit. And I can take this float and I can pass it into any method that accepts a regular float. So perhaps the system.math calculations. I can declare a function and say circumference does not have to be feet or inches. In fact, you give me any unit. I don't care what your unit is. As long as you give me a length and a width of the consistent unit, I will perform this calculation and return to you my results.
So it infers they're identical from that?
So where it infers that they must be identical is it's actually in the addition. When you're adding or subtracting units of measure, they must be exactly the same unit of measure. So I have circumference, feet and feet, inches and inches. But if I try to send in feet and inches, I have a compile time error that says you can't do that because you told me it was going to be feet, and now you're giving me inches. That's different things. For multiplication and division, if I give you a distance and a time, I can calculate speed as distance over time. So our distance, remember, is 50 feet. Our speed, supposing that we have 0.37 seconds to go over the distance of 50 feet, that would be a speed of 135 feet per second. So I can do these calculations. I can make sure that my math is accurate and that my conversion factors are correct, so I don't accidentally divide when I need to multiply, or that I add two things that are not the same, which are common problems when we're working with calculations. Questions on units? Because this could also conceivably solve the problem of height versus weight, where somebody could put in the wrong thing, where if you adorn the unit on that height, then at compile time, if you're able to know the number at compile time, or you're able to know the type at compile time, then you could check it and make sure that things work. So if I have a function that gives you a height, we're going to slap inches or meters or centimeters on it, and we're going to operate on that in a function that accepts a height.
Right. It was a different vendor's app that was using the user interface.
Yep.
I was strictly on the back end doing data consolidation. That's just one of the things, data quality we ran into.
That's fair.
Oh, we got an error.
Yep.
How do we spot these errors?
Right.
What is the syntax that lets you say inches, meters, centimeters are all like measurements?
So how do you define that this thing is a measurement? You really don't. The only thing that we can say is it is a unit of measure. In other words, I don't tell you that the type of measure is currency, or the type of measure is time, or the type of measure is whatever. So as I just mentioned, I could have currency. I could have US dollars and Canadian dollars. So I don't accidentally add US dollars, Canadian dollars, and Japanese yen. You can define the measures as anything you want, any class that you want. And if you have ways of converting between them, you can create conversion functions. If you don't have ways of converting between them, you can ensure that you don't accidentally combine them together.
Like, so you don't actually accidentally send a rover through the surface of Mars?
Yes, I was explicitly avoiding the rover conversion mistake that everybody brings up when talking about units of measure. That is accurate. Also, everybody does bring it up when they talk about units of measure, because it was a big problem that it came from. One group was sending in expecting inches, the other group was expecting centimeters, and the two are not the same.
Wasn't there a lunar lander?
That was the Mars rover.
No. Recently, Indian space program crashed into the backside of the moon.
Yes, so that happened as well, but I don't know the reason why.
Okay.
So can't guarantee that was unit conversion. Because the Israeli one also crashed into the moon.
Oh, maybe it was Israeli.
Well, the Indian one did as well. Both of them did. Moon people don't like lunar landers. That's so wrapping things up. F# is going to extend our native .NET type system. We have ints, we have strings, we can build classes. But we've got more stuff. I can build option types. Yes, no, maybe it exists. I can build product types, a tuple, collection of and, sum type, or one of these things. Unit type, it's there, but I don't care. Custom types, customer. Units of measure, feet and inches. So I can get all of these things. Most of them I can get in C# as well. There's a couple that I cannot. But most of this is C# applicable too. If you would like to learn more, grab the slides, grab the demos, get links to additional resources. Go to csmore.info/on/types. If you have any questions at all, please feel free to reach out to me. Meetup, email, Twitter, smoke signals, kidnapping children, whatever. Thank you very much.